Hey guys, so today we're going to be talking about pointers. This is the most overhyped concept in C++, I believe, so I want you listeners to try not to overthink this. It's just a memory address where there's data. So let's think about this in a use case by going over to VS Code. As an analogy we're going to test with, we have a neighborhood we want to check mailboxes. So we're going to make a function, takes a mailbox as a parameter, and returns how much money your rich great aunts in Massachusetts send you, and it's in the mailbox, okay? So here we have this function getMail that takes in a parameter of a mailbox struct. All this does is just pluck the money variable out of the passed in mailbox and return it. But look how much data is in this struct. We look up here, right? There's not only the money inside, but the mailbox number, how many people it's serving, the zip code, the initials of the family. It's a ton of data. When we pass this in, what our CPU is actually going to do is make a completely new structure in the local memory of this function, then copy all these values into this new structure. So if we add up all the bytes being copied over from this mail parameter to this mail, we're going to get about 18 bytes because it's 4 integers, which are 4 bytes each, plus 2 chars, which are a byte each. And that's not including padding. So we're going to have that overhead of copying 18 bytes over. And if you have, let's say, a struct with 2,000 variables, 3,000 variables, or if you have an array with a ton of different variables inside of it, 10 different objects, variables of this object, you're going to get to a lot of copying going on and a lot of overhead every time you do anything. So I would say this is equivalent to getting your mailbox, ripping it off the pole that it's on, and photocopying everything inside of it and painting the new address on the box. It's complete overkill. So what's the intuitive thing you'd suggest if you want to read how much money's in your mailbox? Go to your mailbox, open it, and read how much money's in it. Not copying it over, just finding your mailbox, going to it, opening it. That's pointers. Genuinely, it's just the CPU walking until it gets to the address for our mailbox, opening it, and reading it there in memory where it is. So pointers are the most powerful thing in C++ by far. It gives you a performant way to access and modify memory, and if you use it correctly, it can simplify code a lot. So let's recode this getMail function with pointers, but this time, how about we take the money out of the mailbox? Because obviously, we're not just looking in there to see how much is in there. We're not doing saves here. We're taking the money out. So we're going to pass a pointer to the mailbox, get the money in it, save that money, modify our mailbox to have 0 money, and return the value that we saved before. So let's do that together. First things first, let's change this mailbox parameter to be a pointer to a mailbox. So in C++, to declare a pointer, we're going to have to put an asterisk next to the data type. So we're just going to add that here. Now, if you look at this function, the parameters make sense. But when we think about how we're accessing this data, it's incorrect. So when we use the dot operator over here, right, the CPU knows the layout of the object, which is mail. So things like the base address, the last address, which would be last initial in this, because that's the last variable in here. Then, things like variables, like their locations inside the structure, etc., right? But we're not giving it an object. We're giving it a pointer to an object. So this is just an 8-byte memory address. This is not something we could just use dot on. So we need to dereference this address, basically tell the CPU go to this memory, and then we're going to be able to use it as an object. So the way that we do that is arrow. So this arrow operator lets you do essentially the same thing as dot, but just with pointers, and it makes sense because that's what you're just telling the CPU go to this place and then access memory here. So we're gonna modify the mailbox now to have $0 after we take the money out. It's pretty simple. Do the same thing. Maybe this time, how about we switch it up a little? Because there's 2 different types of dereference operators. There's dereference operators like what we just did with above with the arrow, and then there's different reference operators like this. So you can put the asterisk at the start of the variable, and that'll tell the CPU to go to the memory address. So we can do that, and then we can use dot because we already went to the memory address. We can do it like that. I would not recommend it doing it like that, but let's say you have like an integer pointer, you're gonna have to dereference it. Like if you have like, let's say like in x equals 0, and then you want to have a we need a pointer to x, so int y equals %x. We'll get to the ampersand in a second, don't worry. If we want to, I need to make that pointer. If we want to dereference y, so we go to x, we have to do that. So the asterisk is used in declaration of a pointer. It's also used in the dereferencing of a pointer because it's also a dereference operator. So two different dereference operators. So we're going to use that to set the money equal to 0. And the last thing to change is just the get mail call, where right here we need an ampersand. Told you to get back to that. So the ampersand is just how you get the memory address of a variable inside of C++. And I would love to tell you how to remember it, but it's just memorization. You just have to know it's an ampersand, it's a asterisk, it's a arrow operator. Once you practice with it enough, you will absolutely memorize it. Like, it's very, like, to me, it's ingrained in my brain that I don't think about it. I just type it out. One of the really nice things about pointers is that not everything has to be returned. So you can pass in parameters and change them inside of the function, like we did here, right? So if you had a struct maybe like 20 variables, like a physics simulation, and you pass that struct in so you can modify x and y coordinates, you wouldn't need multiple functions to return every value. We can modify it all at once inside one function. Sometimes you need to split up more because, of course, you don't want to have all of your code inside one function. That's bad. But code clarity needs to do different things depending on the context. So sometimes it's really nice to just have something like this. So here, having two functions, one for giving you money in the mail, which is this, when the return statement, and then one setting the money equal to 0, it's very unnecessary. You could just have it in one function like this, and then it's beautiful, and we don't have to worry. Now, it's important to remember this is an analogy. Of course, we could just use mail money inside of main. Like, if we just get this and go, this will compile and run, and it'll do the same exact thing, right? But if you're writing, say, an anti-cheat for a game, and you're trying to prevent cheating by checking if players are teleporting around or getting items that they weren't supposed to, that is a lot of logic that you don't want to have to do inline. You'd have to check for things like ping, distance moved per tick, packet loss, whether the trick shot this player did was humanly possible, things like that. Like, you want it in its own little function that can do its own thing while you just get like a return code denoting what kind of cheat, if any, is occurring. That's the basics of pointers, but in a future video, we'll be elaborating more on different kinds of pointers you can do, like smart pointers, and why you have to be careful with them in a cybersecurity perspective, because that's what I do. I break people who use pointers. So have a good day, and I'll see you on the next one.